right, so we're looking at 5.7, addition of polynomials. I'm going to start with talking about what descending order means. Descending order means going from the largest or the greatest to the least. And for this lesson, we're talking specifically about exponents. So when we're looking at the problem I have here, if I was going to write this in descending order, I would start with the highest exponent. Looking here, the highest exponent is the 7. So I'm going to write 4y to the 7th power. It's positive. So I'm going to cross it out. That way I know I've already used it. My next highest would be the 5. It's plus 2y, so it's a positive 2y to the 5th. Again, I like to cross it off for my visual. And then to the 4th power, it's positive. Cross it off. We're left with these two down here, the y to the 3rd, which is minus 3y to the 3rd. And then this one has no exponent. So we're looking at just the 5. Most of the time we're going to write our answers in descending order. So we'll be doing that when we do the examples here in a moment. So just keep that in mind. So we're talking about addition of a polynomial. And when we're talking about addition of a polynomial, we're adding it together. What it means is, look here. There's nothing in front of these parentheses. And you should remember by now that the first thing you want to do is you want to get rid of your parentheses. Parentheses. Every time you see them, get rid of them. So we're going to get rid of the parentheses because there's nothing here. So we can just drop those parentheses. There's actually a 1, but 1 times 3x to the 3rd is 3x to the 3rd. Looking here, we have a positive. Looking at that, we technically have a 1, remember that. But a positive 1 times 4x to the 3rd is 4x to the 3rd. Positive 1 times negative 3x to the 2nd is negative 3x to the 2nd. Positive 1 times 2 is 2. So I'm going to, kind of in my mind, imagine that I'm distributing that 1. And I'm going to get 4x to the 3rd minus 3x squared plus 2. Now we collect like terms. Oops. There we go. When we collect like terms, we're looking for the same exponent with the same variable. So here is an x to the 3rd, and here is an x to the 3rd. So we're going to rewrite it, and I want to see this step on your paper. I cross them out as I use them. Positive 4x to the 3rd. I look for the next thing that's similar. Well, I've got an x squared, kind of thinking of descending order again. That would be my next thing. There's no other x squared, so I'm going to put minus 3x squared. Okay. My next thinking of descending order is x, and there's only that one x, and it's minus 2x. I've got negative 4 and positive 2. They are similar. They both do not have a variable. So I'm looking at negative 4 plus 2. While collecting like terms still, these two are like. So we add them together. They both have x to the 3rd. 3 plus 4 is 7x to the 3rd. Remember, candy, corn, and Smarties. I can't add this to this because this is x to the 3rd and this is x squared. This is candy, corn, and Smarties. They're two different things. When I'm adding these two together, I don't change the x to the 3rd. It is still x to the 3rd. If this was 3 candy corn and 4 candy corn, I would have 7 candy corn. It doesn't change that variable. Here there's nothing, and again I like to cross them out again. Here's nothing to add the x squared to. Candy corn and Smarties, only add the things that are similar. Here's only x there. And now we're looking at the 2 with no variables. So negative 4 and positive 2, one is positive, one is negative. We subtract them, and I get the 2, which is larger, a 4 or a 2. A 4 is larger, and the 4 is negative, so my answer should be negative. And there's my answer. Let's look at another problem. It is still addition. So in this case, there's just that one again up here, so I can get rid of my parentheses, get rid of parentheses every time. So I have 3x to the third y plus 6x squared y to the third, just writing it without the parentheses because there's only a positive 1 up here in the front, and if I distribute it, it doesn't change. Same thing here, positive 1 in front of all of this. So in my mind, I'm distributing that positive 1 to everything. A 1 times 2x to the fourth y would be 2x to the fourth y. A 1 times negative 4x to the third y would be negative 4x to the third y. Again, 1 times 6x would be 6x, and 1 times negative y is negative y. Now we need to collect our like terms. That's really important. That should be something you do right after you look at your parentheses, is collecting your like terms. So we're looking for anything that has an x to the third and one y. So this is x to the second. This is just x. This is x to the fourth. Here's x to the third and y to the first power. So we're going to put those together. 3x to the third y, cross it out, minus 4x to the third y. You see that minus needs to go along with it. My next one that I'm looking at is x to the second, y to the third. So I'm going to cross it out, and I'm going to look again. Do I see any x to the second, y to the third? No. So I'm done with that. Moving here, I have minus 4x. So all it has is a single x. So I'm looking for just an x, and here's just an x, 6x. Positive 3. It's the only one I see with just the number. This one is 2x to the fourth y. So I'm looking for x to the fourth and y. And all I have left is just a plain y. When adding together, remember your candy corn and Smarties. These two are exactly the same variables. X to the third, y. I can add them together. 3 minus 4 is negative 1 x to the third y. You'll notice that the variables stay the same. They stay the same when you're adding and subtracting. So just like I said before, if this was 3 candy corn and 4 candy corn, 3 take away 4 would give me negative 1. Crossing this out so that I kind of keep a visual. This is the only one I see with x squared, y to the third, so I just move it down. Here's 2 with just a plain x. So negative 4x and positive 6x. I subtract. 6 minus 4 gives me a positive 2x. I know it's positive because 6 is bigger than a 4. 6 is positive. 6 Smarties take away 4 Smarties. I get 2 Smarties. Cross them out. Here we're looking at 3 because nothing else happens. 2x to the fourth y and minus y. So now we would probably want to put that in descending order. And what we're looking at is typically we go alphabetical when we have more than one letter. So the x is what we're going to look at when we're doing descending order. So here's an x to the fourth power. That's the highest one I see. It's positive. Done. My next one I see is x to the third. And again, all I'm doing is shuffling them like pieces to a puzzle. I'm just moving them around. Here's an x squared. Now here I have just the x. And then it kind of depends on how you write it. Here's no x but a y, and here's no x and no y. So I would probably do that, and it's kind of a personal thing as to what is correct. Either way, putting the y second or first in that situation would still be correct. Let's try one more problem like that. Scoot in just a little bit here. All right. So again, we're looking at nothing here, so it's a positive 1, which makes no change. So I just drop the parentheses. Anytime we see those parentheses, we want to find a way to get rid of them. That should always kind of be your first thought in any problem you're attacking. Here we're looking at plus, and again, we're going to be distributing a positive 1, which changes nothing, so we can just drop that. 5m to the third, 2m to the third n squared, 3m minus 2n minus 2. Be really careful when you have this much. It's very easy to mix your n's and your m's up, so just take it slowly. So now we're going to do our collecting our like terms. Oops, and I don't think you have that, so all I did is I wrote for myself, collect like terms, just so I keep remembering the pattern. The fact that there's an addition, I got to get rid of the parentheses. Now I'm going to collect my like terms. So again, I start left to right. So here's an n to the third. Let's see. And there's no other n to the third. So I'm just going to write that down, n to the third. All right. My next thing is m to the third, n to the second. M to the third, n to the second. Here's m to the third, n to the second. So I write that one down. That's a positive m to the third, n to the second. Boom. Here's just an n. So I'm looking for any other plain n's. And here's another one, minus 2n. Here's just the plain number 3, minus 3. And here's the plain number minus 2. And then I'm looking at what's left, and they're not like. One has m to the third and one has m. So I'm just going to copy those down. All right. Still collecting our like terms. So we said this was the only one like it. So I just rewrite it, cross it out. These two are like terms. They have exactly the same variable. M to the third, n to the second, m to the third, n to the second. You have negative 3 and positive 2. You have 3 of them and you have 2 of them. This is a negative. So when you have one positive and one negative, you subtract. 3 minus 2 is 1. So m to the third, n to the second. 3 is a number that's bigger than 2, and 3 is the negative, so it tells me my answer is negative. Looking here, you have negative 5 and negative 2n. They're both negative. You're going to add them together, and they're going to stay negative. Negative 5 and negative 2 is negative 7n. Negative 3 and negative 2, again, they're both negative. I add them together. Negative 3 and negative 2 is negative 5, and they stay negative. The last two, if we remember, they had no friends, nothing to pair them up with. And that's our answer. Now we're going to try to put them in descending order. We'll have a little bit of a tough time here, but not a big deal. Again, alphabetical. So we're going to start with the m. And we see that there's an m to the third and an m to the third. Again, I think what I would prefer personally, and again, it kind of depends on who you are, I would put this one first. There is no right or wrong, to be honest with you. And then I would put this one. I can't add them together because they are still candy corn and Smarties. This one just has m to the third. This one has m to the third and n squared. So we're looking only at the variables when we're adding and subtracting, and these are not like. Now we look for anything else that's m squared. No m squared. So our next one would be m by itself. Now you can now start in with the n. Here's n to the third. N by itself. And all I'm left with is the 5. Gets a little more dicey when you have two variables, but it's kind of starting with that alphabetical, which letter comes first, and then moving on to the second letter.